Hello, and welcome to today's daily Leetcode challenge. Let's begin question 2610. Convert an array into a 2D array with conditions. So this is a medium level question, and the description is you're given an integer array nums. You need to create a 2D array from nums satisfying the following conditions. Okay, so we're given an input of a list of integers, and we have to return a nested list of integers. The conditions by which we create the 2D array are: the 2D array should contain only elements of the array nums, so no new elements are being created or added. Each row in the 2D array contains distinct integers. That means that each row has distinct integers. That's fine. The number of rows in the 2D array should be minimal, meaning that we have to stuff as many unique integers into the first couple of rows as possible. Okay, return the resulting array. There are multiple answers. Return any of them. Note that the 2D array can have different numbers of elements in each row. Okay, so the shape of the 2D array doesn't have to be an n by n. Each row can be of different shape, which kind of visually, this to me looks like a 2D array where the first row is going to be the largest. It's going to be the one that we fill the most in. And then once we fill in the first row, if there are any integers that happen to already exist in the first row, we're going to have to create new rows below the initial row and try to fill that in. So, by the way, the number of rows in the result is going to be the number of the most frequently appearing number in nums. Okay, let's look at an example. We have 1, 3, 4, 1, 2, 3, and 1. I just right off the bat see that 1 repeats 3 times, and that seems to me like that's the only one that repeats most of all. And there we go, we have three nested arrays. The first one contains 1, 3, 4, 2. You can see that none of the numbers repeat there, 1, 3, and 1. And the explanation is we have created a 2D array that contains the following rows: 1, 3, 2, 1, 3, 4, 2, 1, 3, and 1. All elements are used. Each row of the 2D array contains distinct integers, and there we go. We have a valid answer. The next one is even more simpler. The array only contains unique integers, so the result is a nested array of 1 row. Conditions or constraints make it seem like there aren't going to be a lot of elements in the input array, so we can use that to our benefit. This is what I'm thinking. The fastest way to check if something is in some sort of structure is the structure that is best used for those scenarios is some sort of hashing structure, something that lets you hash quickly, and those are either keys for dictionaries or hash tables or maps or sets. In Python they're called sets or hash sets. So my idea, I guess, is to have a return value that's an array, and then I'll have another structure, maybe a dictionary of key value pairs where the key is the index of a row and the value is going to be a set. That set will represent what elements are currently in that row. And so with each new num that I'm exploring, I will go row by row starting from row 0 and check if the element num that I'm currently looking at exists in that set. If it does, then I simply move on to the next row, and if it doesn't, then I found my row to which I'm going to add this new element, and I'm good with just returning it. Okay, so let's begin coding. I'll have the result. I'll have the row dict that has the set as the default value. I'll start for num, and nums. I'm going to be exploring each num. Let's start at row 0 initially and say that if num, while num in row dict at a specific row, I'm going to increase my row that I'm exploring. Once this loop stops executing, that means that I've found the row to which I have to add this num. So now let's add it. Let's first also check if the row for that number actually exists, for that row actually exists, if the array for that row exists. The way to do that is if len of res is smaller or equal to the row, and currently it is equal to, then I'm going to say res append, and then I'm going to append an empty array. Once I do that, that means that I now have a place to put my num, and I'm going to say res at a specific row, append the num. And that's it. At this point, I should have a totally filled result. Let's return it. Return res. Let's see if this works. And it does not. What did I do? I've completely forgot to use my row dict. So the row dictionary, as I said before, is going to be the thing that keeps track of adding numbers to sets. So it's going to be the thing that tells me if an element already exists in that row. So I'm going to say row dict at a specific row, add num. And there we go. Now it works. And we're good. Now also, one more thing that I'm thinking right now, and we're doing not so good. I could theoretically just completely reuse this row dictionary. Why? Well, because I'm thinking that if I have this condition here, couldn't I turn each set into just a list? So let me do that, because I mean here's what I'm saying. Print row dict. If I was to print this guy right here, you'll see that I would have elements, or my default dict actually already contains this structure, the one that I need. I'm just using it. I'm just basically reusing it. So I want to quickly try to I want to see if I can remove having to use this at all. Let me say list, and then I'm have a map of the lambda x, where x, let's turn this into a list, and the values that are going to be going in there are row dict values. Let me print this first. Let's see what sort of structure we're getting there. Oh, and we're doing well. So what I did here was I mapped each value of the rows dict into a type list, and then I wrapped the whole thing into a list. So actually this could also work, I believe. What's not going to work is if I don't map, or if I don't what is it called, cast a set into a list. But here I'm getting away with basically needing that res entirely. And unfortunately that doesn't run any faster. Let's see what is going on here. Res append set. Very interesting. This is the same approach, except he's able to... do I really not need this cast here at all? Wait, could I just return this? I really doubt it. What? That's absurd. Somehow values gets cast into a list. Interesting. I didn't know that. I thought that you have to cast explicitly sets into lists in order for the result to be true, because we're actually returning the lists of list event. Apparently it does casting automatically, and we're able to return a list of sets, and Python interprets it as a list of lists. And alright, that works for me. This works a lot faster. We're now at the 93rd percentile, and the code is minimal. I would say even better than what I've seen before on the 100th percentile. Alright, with that, I guess let's end today's video. It's going to be pretty quick, but thorough and very self-explanatory and intuitive. Alright, well thanks for watching. Please like and subscribe, and I will see you tomorrow. Bye.